Black holes aren't just cosmic vacuum cleaners, they're nature's ultimate time-bending machines. From Einstein's groundbreaking theories to modern observations, we'll explore how these mysterious objects twist time itself and what that means for space exploration. Let's explore how black holes play with time and space like they're made of rubber. Imagine throwing a heavy bowling ball onto a stretched-out bedsheet. The weight creates a deep dip in the middle. That's similar to how massive objects like black holes bend the fabric of space-time. The closer you get to a black hole, the more extreme this bending becomes. Time moves slower near a black hole compared to Earth. If you could watch someone fall into one, they'd appear to slow down and freeze in time from your perspective. Meanwhile, that person would experience time normally, but would see the rest of the universe speed up like a fast-forward video. This isn't science fiction. It's a real effect called gravitational time dilation that we've measured even around Earth, just on a much smaller scale. Let's jump back to 1905, when Einstein turned our understanding of time upside down. Before him, everyone thought time was like a steady drumbeat, ticking away the same for everyone everywhere. But Einstein had a different idea. He realized time could stretch and squeeze like a rubber band. His famous theory showed that time isn't fixed. It changes depending on how fast you're moving and how strong gravity is around you. He proved this with some clever thought experiments, like imagining light bouncing between mirrors in a moving train. These ideas seemed wild at the time, but they perfectly explained why time moves differently near heavy objects, like black holes. Scientists later confirmed Einstein was right by comparing super-accurate atomic clocks at different heights above Earth. The higher clock actually ran slightly faster. Now we're arriving at the most dramatic part of a black hole, the event horizon. Think of it as a cosmic point of no return. Once anything crosses this boundary, even light itself can't escape. But what makes this region truly mind-boggling is how it affects time. Right at the event horizon, time slows down so much that it practically stops completely. If you were watching someone fall toward it from a safe distance, they would appear to move slower and slower, eventually freezing in place like a paused video. However, from their perspective, time would feel normal, but they'd see the entire future of the universe flash by in fast forward. This extreme time warping happens because the black hole's gravity is so strong at this point that it completely overwhelms the normal rules of space and time. Let's talk about one of the strangest effects of a black hole's extreme gravity, spaghettification. As you get closer to a black hole, its gravity becomes so powerful that it stretches everything like pulled taffy. Your feet would feel a much stronger pull than your head, creating a stretching force that would eventually pull you apart. Even your trusty wristwatch wouldn't survive. It would be stretched and squeezed until its atoms were pulled into a thin stream, like spaghetti being pulled through a tiny hole. This happens because the difference in gravity's strength between your feet and head becomes enormous near a black hole. The same force would affect spaceships, planets, and even light itself. It's a perfect example of how black holes don't just bend time, they can literally pull it apart. The wild time-bending effects of black holes naturally lead to an exciting question. Could we use them as time machines? While Hollywood loves this idea, the reality is both fascinating and complicated. A black hole's intense gravity could theoretically let you experience time travel, but only in one direction: forward. By orbiting close to a black hole, you could zip thousands of years into Earth's future while only experiencing a few years yourself. But traveling to the past? That's where things get tricky. Some scientists have suggested that certain types of rotating black holes might create paths through space-time called closed time-like curves, potentially allowing past travel. However, most physicists think nature has safeguards against this, preventing the paradoxes that would arise from changing the past. Let's explore a mind-bending experiment. Imagine twin astronauts, one staying on Earth while the other orbits near a black hole. The effects we see in regular space travel become extreme here. While the Earthbound twin might experience 50 years, their sibling near the black hole might only age a few years. This isn't science fiction. It's Einstein's relativity taken to the max. The intense gravity near black holes slows time so dramatically that these huge age differences would actually happen. We've already seen tiny versions of this effect with GPS satellites, where time moves slightly faster than on Earth. But black holes take this to a whole new level, creating time differences that could span generations. It's like having a time machine, but one that only moves forward. The movie Interstellar actually did a pretty good job showing how time works near black holes, thanks to physicist Kip Thorne's guidance. Remember that scene where 1 hour on the water planet equals 7 years on Earth? That's based on real science, extreme gravitational time dilation. But Hollywood often takes creative liberties. Movies usually show black holes as cosmic whirlpools that suck everything in like a vacuum cleaner, or as convenient portals to other times and places. The truth is more amazing. While black holes do bend time dramatically, they don't work like time machines to the past. They can make time move slower for you compared to everyone else, but you can't use them to go back and meet your great-grandparents. The visual effects in modern movies are getting better at showing what black holes might really look like, especially that famous glowing ring of light around them. When black holes and quantum physics collide, things get really strange. Regular physics rules start breaking down in ways that puzzle even the smartest scientists. At the smallest scales, quantum mechanics says particles can be in multiple places at once and can pop in and out of existence. Near a black hole, these quantum effects mix with extreme gravity to create chaos. Particles appear to escape from black holes through a process called Hawking radiation, seemingly breaking the rule that nothing can escape. Time becomes fuzzy and uncertain. Quantum mechanics suggests it might come in tiny chunks rather than flowing smoothly. This clash between quantum physics and black holes has sparked heated debates among scientists for decades, leading to wild ideas about parallel universes and information paradoxes. The tools we use to measure time warping in space are incredibly clever. Astronomers use special satellites carrying super-accurate atomic clocks that can detect even tiny changes in time's flow. These clocks are so precise they can spot time moving just a fraction of a second differently at various distances from Earth. When we look at light from around black holes, we can see it shift to redder colors. This red shift happens because time is moving slower near the black hole. We've also used pulsars, rapidly spinning stars that flash like cosmic lighthouses, to measure how gravity bends space and time. These measurements have proven Einstein right again and again. Even GPS satellites have to account for time moving faster in orbit than on Earth, or they'd be off by miles. While we can't build a black hole time machine tomorrow, the future holds some fascinating possibilities. Scientists are exploring ways we might use black holes' time warping effects. One idea involves placing spacecraft in careful orbits around smaller black holes to experience dramatic time dilation, useful for long-distance space travel. Another suggests using the energy from rotating black holes to power advanced spacecraft. Some researchers even think we could create microscopic black holes in labs to study time distortion up close. But there are huge challenges. We'd need technology far beyond what we have today, and getting close to a black hole without being destroyed is incredibly difficult. For now, black holes remain nature's most powerful time-bending laboratories, teaching us about the deepest mysteries of space and time. Thanks for joining me on this mind-bending journey through black holes and time. We've only scratched the surface of these cosmic mysteries. If you enjoyed learning about space-time, hit like, subscribe, and share with your fellow space enthusiasts. See you next time.